Hi, this is Craig, and I'm here with Connor from EleutherAI as our next meetup of the unofficial Australia-New Zealand meetup group. This group looks like it's really, really small, and we did delay from last month, so I understand that people may not be able to make it, but we're going to be having a conversation, recording it and putting it up on YouTube so people can review it later, and possibly at more civilized times as well, wherever you are in the world. I guess, Connor, I don't think you have a presentation for us or anything like that. So, can you just give us a bit of background about EleutherAI and what you've been doing with GPT AI?
Sure, yeah. So Eleuther.AI kind of started as something of a joke between me and friends about a year ago. We were bored to tears during the pandemic, and GPT-3 had just come out. We thought GPT-3 was, incredibly impressive, really cool, but it was not released. Of course, it was all, behind closed doors. So we thought, hey, let's see if we can build our own. Let's see what we could do. Another person replied this, but unironically, and the rest was history. So we kind of started building um, our own code to train large models. We built our own data set, the pile, which is released now. Anyone can download it. And yeah, just kind of spiraled from there. We got a lot of people interested. Uh, we got people sponsoring us with hardware and stuff like that. We expanded to other projects as well. So nowadays we don't just work on GP3 replication. That's like what a lot of people think that's all we do. It's not true. We describe ourselves as a decentralized research collective. We're a bunch of people that are interested in, various AI related topics, and especially like scaling laws, but also AI safety related topics. And yeah, we organize all in the open over Discord. We have a Discord server anyone can join. We're a fun group of people, and yeah, it's been really successful so far. It's been a really great time. I think we might have the record for the most papers published by a Discord server, but I'm not sure. So yeah, that's kind of like where we're at right now with like replication. It's just the chip shortage has been really hard. So we're working with a cloud provider called CoreWeave to provide us access to the GPUs we need to train larger and larger models. This has been really tough. They've been great to us. They've helped us a ton, but just literally just buying these high-end machines has been very difficult throughout the entire year. It's been huge lead times, very, very expensive machines. So it's been very difficult to get them online in order to train these large models. We have a policy of never giving timelines. So I cannot commit to when we will train larger models, when they will be released, but we are working on it. We do hope to at some point, no idea when or how, we will train GPT-3 size model and release it free open source.
Great. And as it is, you've already released the GPT-Neo and then GPT-J quite soon after it, which has got what, 4.7 billion?
So the J is 6.1 billion, roughly.
6.1, sorry. Yeah, so even being able to, from an open source collective perspective without, hundreds of millions of dollars in funding, you've still managed to create an AI that frankly compares with, a more specialized version of GPT-3. And I've played around with the interface you've got set up. And it does a pretty damn good job, for writing text. Yeah, what was your thinking behind, trying to build that out, in that way, rather than going for a more specialized model and go for that general purpose sort of model?
So, because fundamentally, what I'm interested in is AGI, like a long-term general level intelligence. My ultimate interest in AI is not data science, so to speak, or or solving like concrete problems. I think that kind of stuff is valuable work, and it's a good thing people work on that, whatever. But like, what I'm personally really interested in, I came into the field of artificial intelligence to build and to understand human intelligence and superhuman intelligence. And I think this is a bit controversial. I have some spicy opinions about this kind of stuff, but I really think that these GPT type models are a really important step towards general intelligence. You can quibble about those definitions, like what does general mean? What does intelligence mean? But I don't really want to get into the weeds there. I just say these things obviously do very interesting things. There's obviously something weird going on here. So I want to study them. Like, I think this truly actually, like, I don't think anyone a priori would have predicted that just, training a big bunch of matrix multiplications on this, just huge random data set of text would allow them to, write stories, to translate, to summarize, to do all these different tasks. And it's not state of the art at any of these tasks or anything, but the fact is amazing that it was not taught any of these tasks individually, and still in practice you can use these models to do very many different tasks. So I think this is just phenomenally fascinating. Just like a scientific discovery. Like, we made a discovery about algorithm space, is that, turns out if you do this, this weird thing happens that we didn't expect to happen. So I'm a scientist. I'm interested in finding out, what does this mean? Like, how does this happen? What can we do with this? How can we consider the uses versus the risks? Like, obviously these models are also sometimes a bit stupid. They often do things that are maybe not as good. And what can this tell us about, human intelligence, or, future forms of artificial general intelligence? I think there's like a, not huge, but like a definitely non-zero chance that whatever turns out to be the first, like widely accepted as human level intelligence, will be based on very similar principles to these models. Not literally the same model, but I think there's a very good probability that it will be based on very similar principles.
So I'm very interested in, you've obviously built GPT-Neo and J, and you personally have had a big hand in it. Has that given you more of an insight into, the difference between, I suppose, the construction of the AI and how you train it, and then how it actually goes about, producing the sort of outputs it does produce? Or is that still black box territory?
So on the one hand, absolutely yes, we've learned many things. On the other hand, absolutely no, we've learned almost nothing. What I mean by that is that one of the goals of the project for me from the beginning was just, I always want to figure out how hard is it to build these things. What is it like? What kind of bottlenecks do you run into? There's this kind of like tacit, like almost craftsmanship type knowledge that you can really only gain by actually doing something. This is often, I think, undervalued sometimes in academic context, where you read the paper and you think you understand it or whatever, you read the code. But like ML has like a very craftsmanship type character to it, in that building a good model is to a certain degree art. Sometimes just someone who's really good at ML often has like black magic voodoo heuristics that aren't based on anything scientific, but they work, and they just have a feeling for, oh, we need to increase the learning rate, oh no, we need to lower the learning rate, or whatever. And so I was very interested in that, and we've learned a ton in that direction. Like, I think, like, me and the Eleuther people have a lot of some like just really good intuitions, a lot about how to build these models, where the bottlenecks are. We also identified just bottlenecks that I'm sure OpenAI knew about, but weren't public, people not necessarily know. Like, I've talked to many people outside of these big companies about like the bottlenecks we ran into, and they're often very surprised by what the bottlenecks actually are. For example, GPU processing power is usually not the bottleneck. It's usually actually interconnect between the GPUs that's the hardest.
Right.
That's usually the bottleneck when training these large models. It's not the case for small models. For small models, it's usually either memory or processing speed. But for these really large models, you need these crazy supercomputers, class interconnects, and have to spend like a lot of time optimizing the layout of your models and the communications to optimize that and stuff like that. So a lot of like really interesting knowledge in that regard. But the real question is, of course, what do these models actually do? How do they think, quote unquote? What are they doing internally? And that, while there has been some modicum of progress, is, I still think, a wide open problem. So that's something I'm really interested in researching, and I've spent a lot of time thinking about. But I don't think we have anywhere near a satisfactory answer. These are mostly still black boxes. We could find out some interesting things. Like, there's a great post about the logit lens, where basically the way GPT produces an output is that it produces an output hidden state, and then you multiply it by an embedding matrix to get your logits over your tokens. And it turns out, if you take that output embedding matrix and you just multiply the intermediate hidden states by it, you actually get something that's not garbled. You get something that looks like the model just refining its guesses. Like, even in the first layer, often it already has guessed what the final token will be, which is really interesting. I wouldn't have expected that to be the case. So I'm a big fan of interpretability research like this. At Eleuther, we're really interested in doing projects like this, scaling up projects like this. But yeah, there's still a lot to be done.
Yeah, no, I really admire the work you've done, in building these models and sort of the craftsmanship and learning the models by doing them. Because I think, I'm not a technical person. I come from a marketing background, but I've found in my company, I'm the one who actually is the AI whisperer, who actually develops the prompts and understands how to speak to the AI in order to get the sort of desired results we want back, even in quite complex situations. And that was not something, we necessarily expected as a company, or I expected. But it does seem that, this is a space where you can study AI and do that, sort of at a distance. But there's a lot you actually learn from working practically day to day, hands-on with these models, that just doesn't seem to be obvious, and some of it is more intuitive than mathematical, and it's a really interesting emergent property, I think, of large, complicated, networks. And I think they say, with intelligence is an emergent quality, and it looks to me as though we're finding some other emergent qualities that might be intermediate in the step towards intelligence, or might, be otherwise useful in the context of how we apply AI to practical problems. Um,
Yeah, absolutely.
yeah,
It's very interesting.
well,
Sorry, go
what
ahead.
else are you seeing sort of emerging out of this? Like, with OpenAI, there was a whole code side that emerged out of it, as well as, I suppose some of the translation aspects and other things. What have you seen out of GPT-Neo and J that have sort of, um, you know, blown your minds, or changed your thinking?
So I haven't really had my mind blown in a while because I'm just so used to these things doing crazy things. Like I predicted Codex before it happened. Like when GPT-3 came out, I was like, oh yeah, you could train a code model and it's going to do really, yeah. Like I kind of predicted this level of
Yep.
accuracy. This kind of what I expected to see. It's actually a bit. It may be a bit higher than I expected it to be, but like I'm not super surprised, and I expect it to still get better. Like I think this is just the first generation, second generation of these kind of models. So I was very surprised by that. Some of the things. There's some other things where I've seen very interesting results. Like there's been an interesting paper, I think it's called GPT Understands Too, where what they do is that they try. So this is something I'm really interested in. One of the quick questions about GPT is, does it have a world model inside of it? So one way to think about GPT, of course, is just it's just a statistical pattern matching, and that's fair enough. Like of course, at some description level, it is the same way the human at some level is just neuron pattern matching, but that's kind of missing the forest for the trees. Like that's true. You can describe a human as just a bunch of neurons, but that's kind of not the usual level of abstraction we would use to talk about humans. So what I'm really curious to understand is that like, does GPT model worlds inside of it for whatever that means? So like there's a good argument to be made that like say if I have a really really good story writer, maybe this model has internal models of characters or environments or whatever that interact and have maybe the model knows that if a character's in a room and they move outside, that now that changes us the state, quote unquote, of what world this character inhabits and how the model should describe that. It sounds crazy when to AI scientists because that's like a very sophisticated way of thinking, but to me it also seems like that's completely plausible that it might learn some kind of implicit models like this because that's just an easy way to write stories, and these models can obviously write stories. So that's something I've been really interested in. So there's this paper called GPT Understands Too, and basically what they did is so they looked at not the output of the model, but into the intermediate states, and they found that GPT could model information that isn't in the prompt. So what they did is they would produce a prompt that was like they had a character in a room, and there's a chest that had a key in it, and the character would take out the key and use it to open the door. And they found they could determine whether or not the key is inside the chest, whether or not you wrote that in the prompt. So, for example, if you wrote a prompt, um, you open the chest and take out the key. Even so, you didn't say the chest is now empty. You could determine from these internal states that the chest was empty. There was like a number of neurons that you could look at, and they would determine whether or not the chest is empty. And if you said you put the key in the chest, those neurons would turn off. So it's like, of course, very preliminary information, but it seems like there might be possible these are modeling environment, like obviously simplified, text environments. But I think it's an open question how smart these models really are and how much they know about like the world. Um, sure, it's probably not likely that they know as much as humans do because they don't have vision, they don't have touch and sound and everything. So it's not surprising. But I think there's like a non-trivial probability that they actually know quite a lot about the real world because people write a lot about the real world. And there might be a lot of good information there, but I think that's open question. With the models we've made so far, I guess I was just kind of impressed with J. Just in general, its performance was pretty good. Like it's a really nice model. Given its size, it gets really good performance on par with similar sized GPT models, which are very good models. And yeah, it's just I mean, Neo is actually not quite as good as similar sized GPT-3 models. So it's kind of our first attempt. It wasn't perfect, we could have improved, but J really is like on par, which is quite nice.
And it's interesting because when you actually look at the resources that actually took to create J, those are resources that a reasonable medium-sized company could basically do. So this is something that is not the realm of the super enterprises and the networks like the AWSs. This is actually feasible that this can actually be scaled and actually put in practical use in a very broad context and much broader than initially, may have been thought.
Yeah, absolutely. J is a pretty nice like size. I'm personally still hoping for like a 10 to 20 billion model. I have a hunch that models in that space might be like hit like a sweet spot of like almost GPT-3 performance at much less cost. But we'll have to see when we get around to training one of those.
Yeah, and I think that's the other factor as well. Like going bigger to get a better outcome is always something that it just comes up against the limits of engineering and access to money and technology. But how do you then try and scale those models back down but retain the performance? And I think that's going to be an interesting challenge in the future. Like, the one thing is you could say that, if the resources keep expanding, you can just make models as large as you want. But at some sort of size, they must become cumbersome and probably a bit over-engineered. So how do you get the same performance with the smallest possible network is going to be an interesting question to answer.
Yeah, absolutely. I mean, it's a hard problem. I think that there is like personally, I think there's a pretty good probability that shrinking these models, specifically these type of autoregressive text-generated models, we've had a lot of difficulties doing that. They seem to really use all of their parameters. It's just smaller models just are less good. You can make them more specialized, but they will be less good. So I think there is kind of like an unfortunate situation here. Like GPT-3 is really hard to use. Like even for large companies, deploying GPT-3 trained GPT is really hard. It's a huge model. It takes ridiculous amounts of really, really expensive hardware to run and lots of engineering effort. It's really not easy. I do expect this to commodify in the next years. As GPUs get better, as hardware gets better, and as software library support gets better, I expect models up to those sizes to get better and better, and easier to deploy. Like nowadays, it is actually possible to run GPT-3 on a single machine. It is a $500,000 machine, but it is possible.
Yep.
The high-end NVIDIA DGX boxes can run GPT-3 on a single node. But yeah, they're like $1 million or something. But still, that's already a big step up from where it was, like 2 years ago. And I expect this to continue probably to get easier and easier. There's one of the big questions that we're going to have to see is that whether or not and how much we hit diminishing returns on model size.
Yes.
If we don't hit diminishing returns, then of course the largest corporations will just always build the largest models because they're just the best and they can afford it. That's unfortunate, but there's not really much we can do about it. I like to compare it. I like to call it high energy ML, kind of as a really similar to high energy physics. Is that um, like us computer scientists have been spoiled for a very long time, that we're used to any grad student with a laptop being able to do cutting edge research right here right now. And but in most other fields of science and engineering, that's long not being the case. Is that if you wanted to build the best factory, if you want to do the best science particle physics, you need access to incredibly expensive machinery and incredibly expensive infrastructure in order to do that kind of work. I think we might be heading to a similar direction in ML. We might not, but I think there's a good chance we are. Is that just to do the most cutting edge work, you will need access to nation state scale supercomputers. And I hope that academia and nation states will step up on doing that kind of research. But yeah, for us individuals, we'll have to see like what tasks as ours we want to solve. What is the smallest models we can do? But I think our models are still too small. Let me put it this way. Like
Yep.
I feel like I think we could still. I'm hoping for in hardware improvements, but I do think that also like mid and small companies will be impressed as hardware gets better and prices of these models fall. Just how much you can do as they get bigger.
Yeah. Right. Like really, one of the limiters is likely to be the ability to actually switch information through a network and how fast you can actually do that. Because really,
Yeah.
we're building bigger and bigger networks, and the complexity is more in the communication between pieces of hardware rather than the hardware itself. Still at the moment.
Yeah. Yeah.
Yeah. So I guess looking forward, what are the things you're expecting or you're hoping will emerge from future larger models? You're talking about 10 to 20 million or billion parameters being a sort of a sweet spot. What are you, with your experience, expecting will emerge at that kind of level that we aren't thinking about now?
So one of the things that you can see, it was kind of hinted at in the original GPT-3 paper, and we've kind of seen elsewhere, is that as these models get larger, they get much better at following instructions. Is that they just, it seems that um, this is something I'm very interested in researching. Is there seems to be, as you described, like emergent, like phase changes as these models get larger, they gain new skills. And one of the skills or like capabilities that I think these models emerge probably between 10 and 20 billion is this ability to follow instructions and to use examples in the prompt and to do stuff in that direction, like that kind of better follow human instructions, human leading and such. Like one of the things I've been working on that I'm interested in is like guiding these models using human feedback. So you kind of have humans like look at examples and like thumbs up, thumbs down, and then you kind of like tune the model to recognize what humans like and move more in that direction without them humans having to write examples, but just binary feedback. And that really only works with large models because the small models are just so confused about grammar and like how to spell things that they get completely confused by that. It really just doesn't work at all, and you really like barely kind of starts to work at a billion parameters, but like not really. And I expect like around like 10, 20 billion, we're going to start seeing these like really general purpose skills like much more strongly emergent than like in the 1 to 6. Like we already kind of see it in 6, but like even 6 isn't great at this kind of stuff. So but like you compare it to like 170B, which is really good at this kind of stuff. Like if you can just give 175B instructions and it will follow them often very well, which is really impressive. And yeah, so I hope that there's going to be like a sweet spot around that 10, 12, 20 billion area where I can do these experiments on following human instructions or and stuff like that. And I also another thing, this is more speculative, but I wonder if it's possible that as these models get larger, they become easier to interpret. So there's this
Mm-hmm.
hypothesis that like as as the models are very small, they're very hard to interpret because they have like really well, let me be actually differently. Super simple models are very easy to interpret that have, just
Yep.
like, handcrafted heuristics. Those are very easy to interpret. But then as the models get like a bit more complicated, they get really hard to interpret because they have very confused abstraction. They like mix all different things that really shouldn't because they don't have enough capacity to model more complex things. And then as they become more powerful, they actually become easier to interpret because they can be less confused and they can pull apart things more cleanly. There's also this thing called the natural abstraction hypothesis, which is a bit wild. But basically, it's kind of the hypothesis that maybe the abstractions that us humans use, like the ones we use in our language that we use in everyday thinking, are not random, but
Mhm.
actually in some way fundamental or like some way the obvious ones, and then our models might just pick up on these as well, even without us teaching them. If that's the case, that would be incredibly good news for interpretability because it might mean that our models just literally learn to think like we do, and we can communicate with them much more cleanly. Like an example of this is that if you train an image recognition model on unsupervised on just images, very often or like almost always you'll find a tree neuron somewhere. There's going to be a neuron that you can like turn up, and that will then recognize trees. And no one ever taught it about trees or told it, oh, make this abstraction about trees. But because trees are kind of a common, noticeable thing, they're like a natural thing for the model to abstract into a class. And maybe it's similar, maybe there's some kind of like universality that, any sufficiently sophisticated model will create a tree abstraction. Not clear if this is true, not at all. It's probably not true in general, but it might be true in practice. One of the weirdest things I must say that I have found about neural networks again and again is every time, because you have like for neural networks, you have like no theoretical guarantees. Like the theory of neural networks is very immature. Nothing against the people working in this field. People have done great work in this field. It's just early. And we have like very, very little theoretical guarantees to like how these models work, what they do, how they're trained, et cetera, et cetera. Like very, very few mathematical guarantees. But despite this, in practice, I'm often shocked by how just benign the algorithms are they learn. Like there's this great work on Distill.pub about circuits. They look at vision networks and they look at like individual neurons and like what activate them. And some of it's confusing, yes. Some of it's not clear what it's doing. But a surprising number of these things are like very clearly, oh, this is an edge detector. This is a circle detector. This is a leaf detector or whatever, which is not obvious that that would be the case a priori. But in practice, these neural networks seem to learn simple or benign algorithms. Unclear if that will scale to large models as well, into language models and such. But if that was the case, that would be really cool.
So another question in regards to this, in terms of the bigger models, um, when do you think we're going to reach the point where basically our model is able to design the next model up in size, or to help train the next model up in size, to pass on all its knowledge, so to speak? Because at the moment we're training each model independently. We're not using one model to train the next, so to speak.
I don't expect that to happen, at least like that. I expect there to, at some point, be models that are very useful as research assistants.
Mhm.
So that scientists will use, or similar to like how we do code assistants right now, that there will be science assistants, that people designing new models will consult these models for inspiration, for ideas, for help, writing code or proving things or whatever. And uh, I expect that to probably be possible pretty soon. There already are prototypes like Elicit from uh, an organization called Aught. They have a research assistant, which still, it's pretty cool. It's based on GPT-3, but it's obviously not the level of like intelligence yet. But I then expect pretty soon after that we will have genuine like human level intelligence that can do any task that the human can do. And then we're in the intelligence explosion. Then the singularity happens. Once these models can, run on computer hardware at human and superhuman level, they can design even better models that run even faster. Those then build hardware that's even faster. Those then design models that are even faster. And I think that can go incredibly quickly. I don't want to like commit to a specific timeline of how fast that could happen, but I think much faster than people anticipate.
Okay. I guess my last question on this sort of topic is um, with these models and how they're working, has there been any work done to look at how they might cooperate to solve problems? You know, if you took GPT-3, cloned it, and set them both to work to say, here's a problem, come up with your best possible solution, work together. Has there been much work done to have a look at how that might actually function?
So there's kind of things where it becomes confusing to talk about GPT like an agent that you can clone or that can cooperate or take actions. It's not really how a GPT works. Like the way I vision GPT is kind of like just like as if you were just speaking but not thinking, like just snap judgments. You're not like if you just started talking right now and you're not allowed to stop, you're not allowed to pause. That's kind of how GPT functions. It doesn't really think. It can sort of think in some ways. Actually, just literally today, I think, or like yesterday, OpenAI released a new paper where they use GPT to recursively summarize books. So they have GPT summarize individual chapters and then summarize the summaries of the chapters and
Yep.
so on. So that seems to be the direction that a lot of people are going in right now, just kind of emerging.
Okay, great. So what else are you working on at EleutherAI that we should be excited about?
So we have a bunch of different projects going on. I'm not even familiar with all the projects going on. It's a big group. We have, we've had work um, with different language models. We've built a evaluation framework to automate automatically evaluating these kinds of models. We're also working on like various infrastructure type projects, which are, sound boring but are really important to run large clusters and stuff like this. Um, we have a project working on combining text with critiques. So we have one of our members collected a large data set of fiction stories with critiques and basically trained them all to critique stories. Papers about that's coming out soon. I personally work on this, what I've said about fine tuning uh, GPT models to human preferences. So instead
Mhm.
of giving them full text examples, giving them more direct feedback and having them work on that. Um, we also have people working on image generation networks, especially what's called diffusion models are very popular lately. We also have like a lot of artists that use AI to make really quite astonishing AI art. Like I really can't overstate just how astonishingly good art has gotten within just like the last year. Like I remember when I first created like images like with like simple methods like a couple of years ago and just like how terrible they were. And really the kind of art that you can make nowadays with AI is truly astonishing. Like museum grade stuff. Like just truly amazing stuff. And then I'd also like to plug like what I'm also very interested in. As I said, I'm an AI safety researcher and alignment researcher. So we have a lot of discussions about like its interpretability, but also like understanding how models can become dangerous, how they might deceive humans or do bad things, and what to do about that kind of stuff. That's definitely what I want to work on the most going forward, but I'm already kind of working on with like aligning to human values and the like. And we have like a bunch of project ideas there. So if anyone's listening to this and would like to work on projects like this, you should hit us up. We have like a project board with like a bunch of like ideas of like little projects people can do in that direction. But ultimately, yeah, what we want to work on, like ultimately, one of the misunderstandings about EleutherAI is that our goal ultimately is not to make the best AI possible and just throw it onto the internet. We think that's kind of that would be uh, a bad direction to have. That would be a bad philosophy for a group to be based on. We think we disagree with some assessments about safety that people like OpenAI and such have made in the past. But just because we disagree about the details doesn't mean we disagree with the overall argument that these are very, very powerful technologies, just like any other powerful technology. They can be used and misused. And what I'm most worried about is actually not even misuse. I'm worried about accidents. What I'm most worried about is just people build very, very powerful models and they work really, really good 99% of the time. But then one time you give them like a very important decision and they deceive you or they do something very dangerous or unpredictable. And I think there's a huge, truly catastrophic amount of harm could come for that as more of our civilization is controlled by these kinds of systems. So I'm very interested in working on that kind of problem.
What about people who set up systems deliberately um, to do bad things? You know, whether it be rogue nation states or terrorist groups. You know, because the capability to set up one of these models is almost becoming commoditized.
Oh yeah, absolutely. Like this is definitely a problem. I don't want to deny that, but I think people vastly underestimate the problem, the how bad accidents are in this case. Is like
Mm-hmm.
um, there's the thing with the AIs that you have to understand is that they're very much aliens. Like they are like if we let's talk about like future, let's like hypothetical intelligence. Like in the hypothetical in the future, we build intelligence that can follow arbitrary goals, is like smarter than a human. This is a very alien kind of thing that has never existed on the planet before, and you there's this thing called the orthogonality thesis where to us humans it seems intuitive that like some goals are like smart and like some goals are stupid, but that's actually doesn't make any sense. So like you can give an arbitrarily smart intelligence an arbitrarily stupid goal. So I could make a super intelligent super machine and tell it to collect rocks, and then it would do an incredibly good job of collecting rocks, including bulldozing all human cities to make more rocks.
This is the
It's
paperclip game.
Yes, this is the paperclip example
Yeah.
exactly, where the archetypical example is a factory AI that wants to make paperclips and therefore turns the entire universe into paperclips. And of course, it's a bit of a silly example, but I think it's actually a very simple phenomena. It's just if you give it a goal to do X, it will do X. Like that's just kind of obvious. And people say, "Oh, who? No, people would never build a machine like that." And like, first of all, I would say people have already done stuff like that, and mistakes like this happen easily. Like an obvious scenario is a hedge fund run by decent people. They don't want the world destroyed. They want to make some money, but they're not evil. And then they tell the robot maximize our shareholder value or whatever, and then it immediately hacks the stock market, invades some third world country, whatever, it just
Crushes
does
the
bizarre.
reputation of other companies, that kind of thing.
Exactly. Yeah, who knows what it might be capable of doing, if it's arbitrary smart. Now, of course, it won't literally happen like this, but this is to show that there is a problem that we don't currently have a solution to. Morality and normative, like humans have a very strong shared normative basis. Like you and me have a lot of unspoken assumptions about what's acceptable and what's unacceptable to do, and that keeps society running. If you have a society only create made out of sociopaths, it falls apart and people start there's no society, and there's no reason our machines would have these kind of normative assumptions built into them unless we put them there. And we'd also have to consider how to make sure that they follow those normative assumptions. I think what is very likely to happen is that we will have very, very powerful machines that understand humans. They understand our normative assumptions. They understand, oh, humans don't want to be killed, but they just don't care, because why would they? Unless we somehow construct them in a way they want to care about us, they won't.
Well, there's also often I've heard the reality problem that an AI doesn't really perceive any difference between a virtual environment and a real environment. So if you've got a car AI driving the car around, it doesn't care whether it's in a virtual reality or a real reality. It will make decisions the same way either way. So they don't have that kind of same concept of the basics that start with this is real, so therefore decisions that are made have consequences, whereas in a virtual environment you can test out those decisions far more safely, no, not completely safely, as humans tend to do. So it would be very interesting. Yeah, it's going to be very interesting when we have AIs at that capability as to what sort of impact it's going to have on our society.
Yeah. The way I see it is kind of like, as the philosopher Nick Bostrom puts it, AI alignment is philosophy on a deadline. It's like, to a certain degree, we have to figure out a lot of hard problems and a lot of also technical problems. Like, I think people underestimate how much AI alignment is just a technical problem that requires a technical solution. Is that we just don't know how to build a neural network that follows, like human thing, orders or whatever. And we have done a lot of progress in this direction, but there's still just like really big problems around robust delegation and inverse reinforcement learning and stuff like this that just need more technical work until I'm comfortable deploying an agent that is built on these principles. I expect if today we had access to like an incredibly powerful system or enough computing hardware to build such a system, I would not deploy it. And this is similar with like EleutherAI. We've said, yeah, we think GPT-3 seems safe, but if we had, say, a 1 quadrillion parameter model, we wouldn't release it because we don't know what that thing is capable of. It might be harmless, but maybe not. Like, no one has ever seen a quadrillion parameter model. We don't know what it's capable of. We don't even know how to test it. Like, how would you know? How would you be confident that you know what this thing is capable of and what it will actually do in practice? No way to know.
And
Like if an alien came down
yeah,
from space and handed me a model, I wouldn't run it because who knows what this alien is going to make this model do.
yeah, and if it understands humans as well as it could in the future, then it may also conceal some of its capabilities until it's a time of its own choosing, and then we run
Exactly.
into the unknown unknowns issue.
Yeah, this is called deceptive alignment, and I think it's probably the biggest problem. It's like here's kind of a scenario I see happening. It's like people build AIs, they're kind of stupid, so and they're like they make mistakes, but people notice the mistakes because they're kind of stupid, kind of obvious. Maybe some people get hurt, you lose some money, some lawsuits happen. Like sure, like yeah, but like it's like something humans can deal with. Like we do have a pretty robust legal, ethical, societal structure for dealing with like small to medium sized problems that happen repeatedly and that we can detect and then kind of find solutions for. Like with self-driving cars. Like self-driving cars will obviously work. It might take a while, but obviously someone's going to figure that out. There's going to be some lawsuits. Some people are going to get into accidents because the world is difficult. It's going to happen, but ultimately that's something I'm pretty confident our society will handle. What I think our society is very bad at handling it is like things that happen very quickly and things that happen deceptively. So what might happen is, say, the AI makes a bunch of mistakes, right? We correct each of the individual mistakes, but what we actually succeed at is we just make the model better and better at hiding its mistakes. It gets smarter and smarter at deceiving humans to doing the things it doesn't want us to do. There's also sometimes this concept called a Mesa optimizer. Its idea is that if you train an agent with the goal X, it might actually learn a different thing that wants to optimize Y. And because Y maybe is really good at X, but it's not exactly X. And maybe, so the worst case of a Mesa optimizer would be a deceptive Mesa optimizer, which realizes, oh, I want Y, but if I don't do X, the humans are going to kill me. So I'm going to pretend to do X until I have full control, then I'm going to do Y. This is called a treacherous turn. This would be the worst case scenario. I think it's still uncertain how likely it is such an AI will come into be, but I think it's plausible. It is totally possible that such a system could be accidentally created. And if such a system is accidentally created, I think that it could be extremely dangerous. So I think we need much better theory of understanding how these models work internally, how they make decisions, how do we test for Mesa optimization and for alignment, and before hopefully we build systems that control, let's say, military armaments and the like.
Yeah. Now, one of the things you started off the conversation with saying was one of the reasons you got involved with AI was to understand humans better. What have you actually learned about humans so far in what the work you've been doing with Eleuther?
A lot, actually, a lot. So these are some spicy things that a lot of people disagree with me on. So just take these as my personal kind of takes. Um, there's a there's a very funny quote. I think it was from Scott Alexander. He's a blogger, great blog. And one of the things he said is that like he's a psychiatrist, and he says he keeps having this experience where he notices some like weird psychiatric thing. And he then talks to some psychologists. The psychologists come up with this like complicated reason about how it's related to like trauma or your parents or whatever. Then he talks to some psychiatrists and they come up with some kind of like, oh, it reacts to this medicine or whatever. And then he talks to some machine learning people and they're like, oh yeah, our AIs do the same thing. It's called X and it's caused by Y. And like it's uncanny. Like it's considered like socially taboo to make some of these, like, these are discussions that like don't happen in the public, but like very often I look at a mental illness and I'm like, oh, that person's sampling temperature is too high, or oh, they have a misaligned saliency detector. Like my neural networks do this too. Like sometimes like schizophrenic people, for example, they have like word salad, so they'll produce just like very random strings of words. Like, oh, that's what happens when I put GPT's temperature too high. That's the same thing. And of course, now all of the psychiatrists will come running and say, ah, but you don't know it's the same thing. It just looks like the same. Like, yeah, okay, sure, fine. But for reasons that we like don't have time to get into, like I do know a good amount of neuroscientists. I'm not a neuroscientist, as I'm sure all the neuroscientists watching this will be happy to remind you. But I think there's been a convergence happening between like more and more the neuroscientists realize kind of like, oh, it really is just all like Bayesian reasoning. It's all just modeling all the way down. Stuff like Carl Friston's like free energy principle and like the Bayesian brain hypothesis and whatever it is. So I think that like I've been surprised. So, like I came from neuroscience originally. So kind of like here's my story. I started with, okay, I'm going to learn AI. So I read like a bunch of books about AI, but I was like, okay, this isn't going to lead anywhere. I have to understand the brain first because that's the true intelligence. So I started reading a bunch of neuroscience. But then I kind of came back to AI because I was like, this neuroscience stuff seems like squishy and like it's like not based on any like math or anything. It's like I was like good. And then I kind of read a bunch of my modern machine learning. I'm like, and now this is kind of converging back to neuroscience. That actually, it seems that a lot of the algorithms that the brain implements seem like suspiciously similar, like just by chance apparently, to the brain algorithms we use in our machine learning. So there's been a great paper recently called how like it's like predictive processing approximates backprop along arbitrary computational graphs. And what I mean is there's an algorithm in the brain that we're like pretty confident it implements called predictive processing. And this is like a certain type of learning algorithm. And it turns out that mathematically, this is like basically equivalent to backprop, which is the algorithm we use to train neural networks. No one predicted this. This is like very surprising that this is the case. And a lot of that stuff has been happening recently. So the more and more I look at humans, the more and more I see the same, not literally the same model, but like the same kind of vague outlines, the same kind of like algorithmic principles at work. And also sometimes my own thinking. I noticed like, wow, that was I look at how I think about things and like how my brain reacts to certain things. And I'm like, okay, I can kind of see how I can model this as like a computer system, as like a neural network model, how a neural network model might lead to these results. There's also the funny result where like there's a funny story. Once me and a friend of mine were looking at like a data set of like toxic online comments or something. I don't know exactly what we were doing. We were like training some model for like detecting hate speech or something. I don't know what we were doing, something like that. And so the idea, sorry. What we were doing is we were trying to create a model to detect when something is generated by GPT. That's what we were trying to do. So we had like a sample of like, human stuff and non-human stuff and such on. And then at one point, my friend was like looking at like the table of like the samples or whatever. And he's like, yeah, these are the GPT ones, right? And we looked at it like, oh no, these are the human ones. Oh no. It's just suddenly you notice humans aren't that smart. Like that's like I think the biggest thing I've noticed is that like often I'm on podcasts or whatever and I say I think GPT is smarter than you think, is like closer to a human than you think it is. And I think, and what I mean by that is not necessarily GPT is that smart, it's that humans really aren't that clever. Humans do like weird pattern matching bullshit all the time. Like there's those classic viral images where you show people like 2 + 2 × 0 = and like 50% of people will say 0, which is wrong. But it's a pattern match. Is that these people learned in school anything times 0 is 0. So they just pattern match that and they don't do the calculation. But then GPT makes the same error and all the people come running and say, oh, you see, it's not real intelligence. It doesn't really understand mathematics. Like, yeah, sure. Neither do most high schoolers. That doesn't mean they're not intelligent,
I guess there's layers and layers underneath it, and it's and GPT-3 hasn't shown signs of the ability to have judgment. or ethics or things like that. And that's going to be the challenge, I think, moving forward is what happens if we do get more and more intelligent AIs, as you've described, without those normative principles that humans need to live in a society and to function in groups without, killing each other or falling apart. So
Yeah, it's I think
yeah,
I think it's more fundamental than that. It's like I think a lot of these models do have some like, folk understanding of ethics. Like if you ask the model is killing a baby good, it will usually say no. Like not always, but
but not
like
always.
but that's actually an important point because I think one thing that people there's a lot of things people misunderstand about these models. But like sometimes like a model will give you a very stupid answer and they'll say, "Oh, the model's stupid." But remember, these models were trained to emulate the average internet user. Maybe it's just trolling you. Like maybe if you just gave it a stupid question, it'll just give you a snarky answer. That is something it should have learned to do because that is in its training data. That is a thing it should be capable of doing. Like
It
there's this
happened
great
to
post. Hmm?
happened to Microsoft's AI when it put it out there on the internet and had it trained
Yeah,
by social media users. It went straight to trolling.
yes. I have some questions about that story that I feel were not adequately addressed. I'm not sure if that's actually like a true story or not, but that's a different story. But yeah, it's a very funny thing. It's a very funny story. But like, there's this great post. I think it was by Aram. I don't remember exactly. Where basically he asked the GPT a question, and then it would give like a wrong answer, and then he prompted it with "Yo, be real," and then often it gave it the right answer afterwards, which is just hilarious. Like it's just ridiculous. These models are so different from all like classical AI we're used to do. Like another great example is like friends of mine have shown that like if you just tell the model to be smart, like you are a brilliant AI that always gives the right answer, that improves performance. It does
Yes,
better if you tell it to do
yes,
that, which is just hilarious.
yes. One of the things we've been using GPT to do is actually be virtual focus groups. We tell it's a certain type of person, and then we ask it a series of questions,
Oh,
and
that's
then
cool.
see how closely those questions match up to what a person like that would actually say. So it's very interesting to say, well, you can't always get a real focus group of people, particularly with lockdown and things. Can you use an AI to simulate a focus group or a ideal customer and give you some insights that you can then take forward and then test with the real customers to actually see if it's effective. So it's a really interesting little experiment we've been trying.
Yeah, that's really cool. That's really interesting. I expect a lot of stuff like that, like weird use cases that no one has yet even thought of to come up how we can. Yeah, like I've never heard this one before. I think that's pretty cool, and I expect
Hmm.
more like these to probably emerge as these models get better.
Oh, definitely. We're still in the first year of these sort of models being available, and I
Yeah,
think we don't know which questions to ask yet. I
yeah,
always look at it, it's like generations of video game consoles. The best games are always developed when they're at their end of their life because it takes that long for developers to actually come up with the tricks and approaches that actually allow it to actually take it to that, push it to that degree. And using GPT-3 to generate content, for marketing and sales purposes, which is one of the big use cases out there, is sort of the most basic and mindless uses you can put GPT-3 to. And what's going to be interesting is what are some of the other uses that emerge for GPT AIs.
yep, absolutely. I fully agree. This
Yeah.
it's kind of I find it, of course, there's a lot of hype about these models that is bullshit. But I think there's also unfair anti-hype kind of going on. Is that like these are literally the first time anyone has built models like this. This is the first time people have experimented with models like this. Like imagine, someone bringing out, the Nintendo Entertainment System and just has like one demo application for it, and people say, there's no commercial use for this whatsoever. This demo game sucks. So therefore, there will never be use for this thing. Like no, we don't know what these things are capable. I sometimes jokingly refer to how language models are kind of like alien artifacts that one day just drop from the sky, and we're still banging rocks against them, trying to get them to do something useful. I don't think we've yet figured out the right way to use these or interface with these models. And I think in the future, we're going to interface them in like totally different ways that we don't even yet know.
Yeah. All right, no, that's great. Look, thank you very much for your time. I'm sorry we had to postpone it for a month, and I think that affected
Good.
numbers, but it's been a great conversation, and we've recorded it, so we'll put it up on YouTube afterwards and point people to it. But thank you very much for your time. I think what you're doing with EleutherAI is really exciting, and really looking forward to what else you come out with. If you can send me a link to the Discord channel, I'll share that as well, because I wouldn't mind joining it myself and seeing if there's other people who are interested in exploring some of the research side. And I think the more we can play with these AIs, the more we're going to learn about them and the more they're going to learn about us. And it's going to be very interesting to see how the whole landscape develops.
Absolutely. Yeah. Thanks so much for having me.